So quadratic functions are those functions that have a second degree equation to it. So we have this exponent of 2, and that's what defines it as a quadratic function. Next week we're going to get into polynomials, and we'll look at all kinds of functions that have exponents that are higher. Still, all of those exponents will still be integers. You have 3 terms for a quadratic function. You have the quadratic term, you have the linear term, and you have the constant term. And when you graph a quadratic function, you get 2 different types of graphs. You either get a parabola that opens up down like this, or you get a parabola that opens up like this. There are quadratics that open up side to side, but they won't pass the vertical line test, so therefore they're not going to be functions. And we're not going to talk about those, but they do exist. But for us, we're only going to look at these. Now, the 2 interesting parts, there's a few interesting points on this parabola. The first one is this point called the vertex. And the vertex represents either the highest point when the parabola is facing down, or it represents the lowest point. When we're doing practical applications with mathematics and our quadratics, the questions that we're going to be asking are, what is the maximum value that I get for a certain function? Not only these are relative max or mins, relative to the little people in your neighborhood, but they also represent absolute max and mins for that function. And so that's why we're going to find them interesting. The other points that are going to be interesting are the points where it crosses the x-axis. And we're going to call those zeros. And the reason why we call them zeros is because the function f of x is equal to 0. Hence the name, we call them zeros. Now you may hear them called solutions of your function or roots of your function. These are all synonymous terms. They all mean the same thing. It means where the quadratic crosses the axis. X-axis here and here. Now, sometimes you have 2 points, sometimes you have 1 point, sometimes you'll have no points. And there are no roots for that in the real number system. Notice that we're starting at section 3.2. We skipped section 3.1, which talks about imaginary numbers and complex numbers. We're taking that out of the course. The other point that you may be interested in is the Y-intercept. And where does that graph cross the y-axis? If you have those 2, 3, or 4 points, then that's going to give you the information about the parabola that's going to be the solution to some sort of answer to the question that you're looking at. Okay? These are going to be the interesting points. Okay? To find the vertex, we have 2 different ways in which we can make that happen. The first way is by using the vertex formula, which is going to be minus b over 2a. And that b and that a come from my quadratic equation. So all I have to do is find out the value for b and a, which will be given to us in the equation, put them into here, and we get the x value for our vertex. To find the corresponding y value, we plug that value in to the function, calculate it out, and then that's going to be our output value. So finding the vertex this way is pretty straightforward. Another technique that we can use to find the vertex of the function is something called completing the square. And completing the square is a technique where you manipulate your trinomial, this is what the function is called, into what we call vertex form. In this vertex form here, this is a form that lends itself to look like the transformations that we talked about last chapter. We have h here, which represents a horizontal shift, and k here, which represents a vertical shift. The original parent function, y equals x squared, that vertex is at the origin. So if you shift it around in this form, your vertex will be h and k based upon what we know from transformations. To find the solutions or the roots, there are three things that you can do. The first one is to factor that equation. You guys have already spent a lot of time in algebra 2, pre-calculus, all of your grade school classes up until getting to this point, factoring by unfoiling. That means taking your quadratic and making it into its two linear factors. The techniques that you've used are probably different than, not everybody's learned different things. Some of you have like the fishbowl method, some of you have the grouping method. My job here is not to rehash all of those methods with you. Go to what you already know. I do some examples in the videos in case it's been a while for you guys, but this is a technique that you guys should be familiar with. I call it unfoiling. I think I'm the only one that does. Because remember, FOIL, you guys know foiling, right? First outer layer less is how you multiply it out. Unfoiling means that you take it from its trinomial and turn it into its two linear factors. Now, the second technique for finding is this completing the square technique that we used before. You can use this completing the square to factor it out. You get into this form, and then you can take the square root of both sides and solve for x. Okay? This is probably the harder of techniques that we can use. Finally, the last way that you can find your roots is by using the quadratic formula. If you take this equation here, and we have an a out here, oops. If you take this equation where you have ax squared plus bx plus c, set it equal to 0 to solve for x, using the technique of completing the square, you end up with the quadratic formula. That is the end result. So, if you memorize the quadratic formula, then you already know how that story ends. You know the punchline. The quadratic formula will work every single time to find out the roots of your equation. Okay? Now, the only reason we don't do it all the time is because sometimes it's actually quicker to unfoil it and to factor it. Okay? Finally, the other points that you may have are the Y-intercept. This one's straightforward. It's just going to be this value of c that you have in your quadratic equation. And it has the coordinate point 0c. Okay? Now, I've already emailed this to you guys, right? So you already have all this. You just don't have it as a recording. So those are the techniques that you're going to use to find those points. Now, as we look at graphing the things and the parabolas, one thing of interest is going to be this axis of symmetry. And the axis of symmetry is a line of reflection right down the middle of a parabola. And that axis of symmetry is an equation of a line, and it's in the form of x is equal to minus b over 2a. So it's not enough to just write down that value for axis of symmetry. You need to actually write out the equation. Now, it sounds like we have a lot of formulas here that we need to memorize. But notice that we have minus b over 2a for your axis of symmetry. To find your vertex, it's minus b over 2a. In your quadratic formula, it starts with, we have minus b over 2a. So this theme of minus b over 2a is prevalent through all of these things that we're going to be using. Why parabolas? Why are they important? Their geometry can be useful for us. Right? These days we have LED flashlights and there's no mirrors behind them. But before we used to have bulb flashlights. And that bulb flashlight would have a curved mirror behind it. And the geometry of a parabola is such that if you take this as a point source of light, radiation, or whatever, and you bounce it off the parabola as a mirrored surface, it'll come out like this. And so no matter where you bounce it, all those rays will be parallel to each other. So it acts as a point of creating a single point light source and turning it into a beam of light. It also works exactly the opposite way. Some of you have heard of DirecTV or Dish Network, when you have little satellite dishes on top of your houses. It takes those beams coming from the satellites and then bounces it to a single collector right here. So it focuses and amplifies the signal for your antenna so that you can receive it. And if any of you have ever had like a mini mag flashlight, yeah, back, it's a little metal flashlight and you can screw and screw off the head. And when you change that, the beam will get tighter, wider, or narrower. And the reason why that's happening is because you're changing the focal length that you have here. If it gets a little bit closer, it's going to scatter the beam. If you get it further out, it's actually going to take all this and collect it at a single point. Magnifying glasses are basically two parabolas on that piece of glass together. And that's what allows you to magnify. Okay?